Hi there! Welcome to the 17th episode of the Synth project, where we are going to build a synth together. What you have just watched was a short example of what we can do with the Softpot. In the last episode we have seen the schematic of its controller and we have tested the circuit in the lab while assembled on a breadboard. It is time now to mount the circuit on its own PCB, create a case for the module, put it all together, install the module on the rack and run some experiments. There is a whole section toward the end of the video exploring several things that can be done with what we have put together so far. Watch the video till the end if you want to see and hear everything at work. Let's start by briefly describing the design of the case module. The module is built from the template that was prepared a long time ago. It has the standard height and has a width of 1 unit, 50.8 mm. The depth has been set to 1.3 units, an awkward number, but dictated by the space needed for the PCB that needs to be mounted on the side panel. Visible in OpenSCAD are also 4 holes to support the PCB in its designated position, which is located farther than usual from the front panel to make sure that the jack sockets that will be put in there won't touch the PCB itself. The front panel has 5 holes in it, going from bottom to top. They will be used for the jack socket connecting the Softpot to the module, the switch for the polarity inversion, the jack socket for the control voltage output, the jack socket for the gate output, and the jack socket for the trigger output. From the back of the panel, note that the thickness has been reduced to a single millimeter on the area of the 3 mm jack to make sure that we can screw the 3 mm jack socket in place, which is relatively small. Here is the printed module case with its support wings already glued to the top and bottom sides. Here are the holes to attach the PCB to the side panel, and these are the holes for the 3 jack sockets, the one for the CV, the one for the gate, and the one for the trigger signals. This hole is for the switch used for controlling the polarization, and this last one is for the 3 mm mini jack socket to connect the Softpot to the controller. To complete the case, it is now just a matter of painting the front panel, add the decals to identify each element, protect the decals with a couple of layers of transparent paint, and finally assemble all the components on it. And here is the case completed with paint and decals. However, the hole for the 3 mm jack is still covered by part of its decal and needs to be cleaned up. And we also have to add the copper shielding on the back. Once that is done, we can start mounting the hardware components on the front panel. The excess decal can just be removed with a sharp knife, and then we can start shielding the inside of the case. The shielding can be done with the same procedure we used for the BCO module, using a self-adhesive copper tape. We just need to cut it to measure and apply to the back of the panel and then on the side panel. I laid the module on a piece of foam to avoid damaging the front panel finish, so I could work safely on the inside of the case. It took a while to attach the tape, which was a little larger than the case itself. And I also made a little mistake. The area around the 3 mm jack for the Softpot connection should not have been protected. Since that jack can be polarized in such a way that the positive of the power supply goes to the jacket of the jack, such polarization will cause a short circuit of the 12 volts to work around. You'll see me fix this mistake later on when I realized that what I did was wrong, fortunately before causing any damage. Once the copper layer is applied, we need to clean up the holes with a knife, so that we can fit the hardware. After that, I apply the copper tape also on the side panel, but just in the PCB area. There is nothing else to protect on that panel, so there is no need to waste more copper tape. And of course, I also had to clear the screw holes. Next, I started mounting all the hardware to the front panel. I started from bottom up. First, the jack connector for the Softpot. Then I attached the switch for controlling the Softpot polarization, for which I had to make a few attempts to set the back nut at the appropriate position to align correctly the component on the front panel. Then I worked on the 3 large jack sockets. First, the one for the control voltage output. Then the one for the gate signal output. And finally, the one for the trigger signal output. Before setting the case aside, I also checked that I didn't bend the jack connections on the back by inserting a jack into the sockets and make sure the contacts were working fine. Let's now work on this PCB. I just received it from my manufacturer a few days ago. It is a 2-layer PCB with a nice silk layer on the top side. The components will be soldered in the central area, while all the connections to the panel and the power supply are lined up on the 2 sides. Let's start mounting the components on it. As usual, I started with the mechanical components. First, the 3 IC sockets. Then the power connector. Make sure you put the power connector in the right direction, otherwise you will provide voltage opposite to what are supposed to be. I actually made that mistake myself, and as soon as I powered up the PCB for testing, the 3 ICs literally exploded, and I also burned at least one of the 2 Zener diodes. Since the damage was big and extended, I ended up remaking the whole PCB from scratch. So make sure you respect the pin numbering. Basically, the connector should not be inserted the way you see it now. Anyway, after the mechanical components, I soldered all the resistors. And then, after that, I soldered the diodes, both the Zener and the 1N4148 diodes. After the diodes, I soldered the capacitors, 7 of them, 6 for the IC decoupling and 1 for the differentiator used to generate the trigger signal. I then inserted all the ICs on their sockets, making sure to respect the position of their pin 1. Once finished with the components, I attached the wires to connect the PCB to the components on the front panel. I used the different colors for the various positions, so I would not make any mistake when soldering the other end to the components. When you do so, make sure you follow the pin numbering as visible on the schematic. Pin 1 on the PCB are those that have a squared pad rather than circular. Pads are very close to each other, and so make sure you don't cause any short while inserting the wires in the holes, and soldering them, of course. Once everything was soldered, I attached the hardware to fix the PCB on the side panel of the module. And then I attached the PCB to the panel itself. I oriented it in such a way that the power connector is facing the center of the case. I also had to play a little bit to reorient some of the jack sockets so they would not touch the PCB. And then I moved to the wires. Before soldering the wires to the components on the panel, I cut them shorter so they wouldn't cause too much clutter behind the panel. When you do this part, make sure you attach the wires to the correct components, otherwise the labels on the front panel will not match with the correct functionality. I kept the 3 wires for the Softpot for last, because I had to follow the schematic to connect them on the switch and the 3mm jack socket, and I wanted to do that with no other impediments around to reduce the chance of mistakes. Once all the cables were connected, I used a couple of zip ties to hold them in place in a neat fashion. And here is when I realized that the 3mm jack socket could not be connected to ground through the shielding, and so at that point I had to scratch away some of the copper tape around the socket to isolate it from the ground, and also I checked the effectiveness of that using a multimeter. I also put some insulating tape all around to reduce the chances that some loose pieces of the copper tape could move around in the inside of the case. Don't put copper tape in that area when you build your own Softpot controller. You will avoid all this extra work at the end. Once the module was completed, it was time for some testing before completing the installation in the rack. and so I plugged the power cable on the module and on the power rail, and temporarily positioned the module in the rack without screwing it in place. Then I connected the module to the Softpot using a short 3mm jack cable, and then I connected the control voltage output to an input of the VCO. I also connected to the gate output the control input of the triangular wave, and connected also the VCO to the amplifier. The sound came alive immediately, and I was able to manipulate the pitch using a Softpot. Also the polarization switch worked fine, as I was able to invert the direction of the Softpot control. However, something was wrong. I wasn't supposed to hear any sound when I was not touching the Softpot. Instead, I was able to hear the low note emitted by the VCO when no control voltage is applied. I tried to see if the gate was providing any difference at all, but it was true, the gate was not working and I was able to hear the sound always. It was time to go back to the drawing board to see what was going on. It turned out that the diode on the inverting pin of the comparator was not doing its job. It was working when the circuit was assembled on the breadboard, but it wasn't working now. The repositioning of the components on the PCB caused some sort of different interaction that made the circuit not to work anymore. And so, rather than using a diode to wave a small positive voltage on the inverting input, I decided to do that using a voltage divider. After a few tests and measurements on the bench, I arrived to the conclusion that these values of 10 megs and 56K were enough to obtain the voltage I needed, which was supposed to be just a few tenths of millivolts. And the bench test suggested that it was okay. But when I went back to the Synth rack, the initial result did not change. The gate signal was always on. The voltage applied to the inverting input was still not high enough. And so I decided to try yet another solution. Since I wasn't able to find a fixed resistor to solve the problem, I used a multi-turn trim pot, connected like in this picture. And you can see how it looked like when installed on the PCB that wasn't done for it. It looks like the electromagnetic conditions inside the rack cause a lower voltage than I predicted applied to the inverting input, and this causes the gate signal to be always on. And because of the unpredictability of this issue, the trim pot was the only solution I could find. Too bad I now have a component that needs to be tuned. I really hoped I didn't need any tuning for this module, but, well, oh well. And so I was back to the rack when I tested the fix and tuned the trim pot. I connected all the necessary cables, and then I powered everything up. I was immediately greeted by the lowest frequency emitted by the VCO, but now I started rotating the trim pot until I found the position where the sound disappeared. Do you see how when the trim pot seems tuned, moving away my hands caused the sound to come back? I had to continue tuning the trim pot and at each adjustment get away from the module to make sure that the new setting was working. When I finally found the right setting, to make sure nothing would happen later on, I went back to the trim pot one last time and rotated it a little bit more to make sure I was deep within the range that caused the gate signal to work. Not too much though, otherwise the gate would not turn on anymore. And once I finished that, everything worked fine. Time to finish the installation, and so I connected the power cable on the far right of the power rail, positioned the module to the far right of the rack so I would be close to the Softpot connector, and then I screwed the module in place. Done, finally. It was now time for the final test. And that ends the demonstration of the capability of the Softpot. I used it to generate a control voltage to control the pitch, but I also used it to modulate a fixed pitch generated through the control voltage from the test module, which is still attached to the synth rack on the side of the VCO. It is now time to start working on a new module, which you'll see in the next episode of the series. In the meantime, let me know through the comments if you have any preference on which module to work next. I'll see you in the next video, and as usual, happy experiments!